Okay. Let me just bring this back up on the screen.
Is recording?
Yes, it's recording. Okay. So I actually, most of you guys had gotten number 1 right. Toledo, what did you have for number 1?
I got 5N.
5N, good. I noticed that some people had written like some variation of that, like x times 5.
Yeah.
That's not wrong, but it's not like the simplest form, okay? That would be marked right, unless it said like what is the simplest form of it, right? Because you don't need the times thing. You can just put them together. And when we have a number and a letter together, which one usually comes first? The number, right? We usually write things like, 3x squared or whatever. If you wrote x5, well, it's not really wrong, but it's not as right as it could be, okay?
Right.
This still means you're multiplying those two things, but we usually write this as 5x, okay? So, if you get in the habit of doing it that way, it's just going to make your life easier, okay? Let's see. Marcus, what'd you get for number 2?
X times 3 plus 7.
X times 3, what was it, plus 7?
Yeah.
All right. So,
Parentheses.
you don't actually need the parentheses here.
You could put 3x plus 7.
Good. The same way we did here, right? Instead of x times 3, to make it simpler, it's really a little bit simpler if you write it like that. Right? What you wrote is not wrong, but it's, we usually, we want to make, mathematicians like things simple, right? So what looks simpler, this or this? Yeah, right? Because remember, we said, when you were probably in 5th grade or something, or 4th grade, I don't even know what grade is taught now, but if you don't see an operator between two things, right, 2 characters or whatever, that means you assume it's what operation? Huh? Multiplication. Yeah. So since you don't see any symbol, any mathematical operator between the 3 and the x, you assume that's multiplication. So this is the same as saying the product of a number, which is the x and 3, and then you increase that by 7. You don't really need the parentheses here. I mean, if you put parentheses here, it's fine. You don't need it because PEMDAS tells you to do this thing first anyhow, right?
Mm-hmm.
PEMDAS says to do multiplication before you get to the addition. So you're going to have to do that first anyway before you add the 7. So you don't really need the parentheses there, okay? Again, if you write it that way, it's not wrong, but it's not as simple as it could be. So far, so good?
Yeah.
All right. Did anybody get this one? Actually, I saw a couple after I helped you. Did anybody get this? Or you want to tell me what you had? Huh? I had one.
7x less than 8.
What did you get?
7x subtract 8.
Say again.
7x subtract 8.
7x.
Take away
8 less than the sum. Well, the 8 less is good.
8.
The sum of a number and 11. Did
Oh,
you say 11?
11. I'm bugging. That's it.
All right, but we're also missing something here. What's sum mean?
Add.
So instead of 11 times x, what does that have to be?
Plus.
So, and I'm just going to write the x first. Again, it's not essential,
Minus 8.
right? So here's the sum of x and 11, or the sum of x, the sum of a number and 11, right? I always say to find your x first, and then work outwards from there. So it's the sum of x and 11, x plus 11.
Mhm.
And then keep going backwards, and it's 8 less than that thing. You could put parentheses here. It's not necessary. In this case, it makes a little more sense to do it than here, though, just to show that, well, here's the sum, and then we're going 8 less than that. But it'll actually work out the same without the parentheses. Okay?
I got you on number 4.
You got me in the last one?
Yeah.
All right, hold on. Let me just make sure. Does everybody get how we just did number 3, though? Right now, again, like the strategy is find your x, or where it says a number or some number, and say, okay, that's my x or my n, whatever letter you want to use, right? And work backwards from there. So it's the sum of x and 11. That's where we got that from, right? And then you just keep going backwards. It's 8 less than that, so it's minus 8. Okay? All right, Marcus, tell me what you had.
X minus 2
Mm-hmm.
divided by x plus 5.
Okay, that sounds good. Because why did you make this into a fraction?
It says the ratio of
This word, remember, now for the people who were here yesterday, we went over a list of the key words and like what operation they tie into. And ratio means division, or think of ratio as a fraction. So you know right away you're going to have some sort of a fraction. You can write that bar if you want. So it's the ratio of, now let's look for our x, right? The ratio of a number. Here's my x. A number decreased by 2, right? We're working outwards here. So how do you write a number decreased by 2?
x
Well,
minus 2.
like Marcus just said, right? So here's a number decreased by 2, or x decreased by 2 is x minus 2. So that's the top part of our ratio. And then the second part says 5 more than the same number. Well, there's your x again, right? The same number is your x. Go backwards from there, 5 more than that. If you weren't here yesterday, this is going to be a lot tougher than if you were here, okay?
Let's see.
Huh? We okay with this? All right, let's move on to the next thing. I'm gonna. Yesterday we got through the whole classwork yesterday, right? So for the people that were here, you were supposed to have finished the homework for homework. Okay, some people gave it to me. Some people, I know that some of you guys weren't here yesterday. Okay. Oh. You know what? I think we should do this one together. All right, hold on to it. So guys, if you didn't finish the homework, let's go over one of these, because it'll actually lead into what we're doing today anyhow. Yeah, the back, the problem on the top. Now, let me also hand out the homework to whoever wasn't here yesterday. There was a number of you guys, right? Who wasn't here yesterday? You were here.
Yeah.
You were here yesterday, right? You were here, right?
Yeah.
We're gonna do number on. If you turn the page over at the top, number 2. Right? It's a word problem, and it's essentially the same type of stuff we were doing, except there's a few pieces, and then you got to put them together. I think that's a good problem to for us to go over together, because this is really the type of stuff that you're going to be doing. You're going to be taking these little pieces and putting them together to form equations, all right? Let me actually bring it up on screen. I hate to do this to you, but I got to sit down for a second. As opposed to me actually writing all this stuff again. Take so much time. Am I in the right place?
Nope, not there.
One lesson. Okay, we're getting there.
Translate English to algebra.
There we go. I just got to get to the homework and the back.
Right there. Right there.
All right, good. All right, so this is sort of like a problem that's made up of a few different steps. And the key to that is always to break it down into the simplest pieces. What happened to this thing? Oh, I know. Can you move? Yeah, of course. Okay. All right, so we're talking about the Miller family. The Miller family made mathematical statements out of their ages as follows. Tom is 4 less than Gary's age, 4 less than twice Gary's age. Rebecca is the youngest and she is 2 less than half Gary's age after it was increased by 3. Sam's age is the ratio of 7 more than Gary's age to 8 less than Gary's age. So, it sounds like a whole lot of gibberish, yeah? But we're going to break it down into pieces. First of all, who is the person here that they keep comparing everybody's age to? Gary. That's going to tell you who your variable is going to be.
Gary equals G.
We're going to use G for Gary's age, right? That's why for this problem, even though we have all of these people, you only need one variable, because they're telling you everybody's age in terms of comparing it to Gary, okay? So for Tom, it says, Tom is 4 less than twice Gary's age. Gary's age is our variable, that's our G.
So 2G minus 4.
2G minus 4, right? Twice Gary's age would be 2G, and then it's 4 less than that. Good. Everybody get that? Rebecca. Now Rebecca's a little, let's see, she's the youngest and she is 2 less than half Gary's age after it was increased by 3. So, okay, here's Gary's age, that's your G, right? Half Gary's age. It's going to be 1/2, actually let's go this way. Gary's age after it was increased by 3. Good. So, G plus what?
3.
Very good. It's got to be half of his age after it was increased by 3. So you have to have the parentheses, meaning first you got to add the 3 to his age, then you take half of it. But it's also something less than that. She's 2 less than that.
So I can go in the back -2.
-2, perfect. Good. Right? So first you have to add 3 to Gary's age, take half of that, and then take away 2. That's the hardest one, I think, right? Sam's age is the ratio of 7 more than Gary's age. So Gary's age, that's your G. How do we write 7 more than Gary's age?
Plus.
G plus what?
So,
The ratio means
over
to 8 less than Gary's age.
G minus 8.
Oh.
G minus 8. All right, now you're done with your definitions and stuff. And then, of course, we still have G over here, right? G is he's the one that everybody compares their age to, but we still have to figure out his. Let me just see what the question says now. If Gary is 11 years old, oh, so they're telling us how old Gary is now. First of all, is anybody confused about how we got any of these? Right? You see how, like, if you just read this thing all together, it's like, oh my God, what the hell is this, right?
Break it down.
But if you break it down, each one separately, and then just, find Gary's age each time, write your G, and then twice G, that's 2G, and it's 4 less Y. It's a lot easier when you break it down like that, no? So, they're saying here that if Gary is 11 years old,
So G equals 11 now.
then how old are each of the family members? So how old is Tom?
G is 11, so 2 times 11 is 22. Take away 4 is 18.
22 take away 4 is 18. Good. So Tom is 18 years old. Right? That's Tom. Rebecca is,
But for that one, I did parentheses, so I did 11 plus 3, which is 14. Bring it down. After 14, that's well, I got
11 plus 3, sorry. All right, 11 plus 3 is 14. What's half of 14?
7.
And what's 7 take away 2?
5.
So since she's the youngest, so far we got Gary's 11, Tom is 18, and Rebecca's 5. So we just got Sam to
What you
do.
did in the middle,
Huh?
that's 11 plus what?
11 plus 3. I just plugged it into here. Yeah, I wrote 4 for some reason, but it's 11 plus 3, which is 14. Half of 14 is 7. 7 take away 2 gives you the 5, right? All right, so the last one is Sam. So it's going to be 11 plus 7 over 11 minus 8. So what's 11 plus 7?
18.
What's the parentheses?
Over 3.
Here?
Three.
11 plus 3. Sorry about that. What's 11 take away 8?
3.
And then what's 18 divided by 3?
6.
Okay?
Wow.
So we just figured out everybody's age.
That's
Now-
a lot of pleasant.
Well, yeah, but at least you already have the equation. Once you have the equation, it's easy to plug it in, right? To be honest, usually the problems aren't this easy. Usually when you get to this point, then they would give you something where you'd have to combine these somehow. And it would say like, when you add Tom's age and Rebecca's age, it equals 32 or something like that. So you'd have to say this thing plus that thing equals 32 and then solve. So here we're just practicing writing what the little expressions are, okay? So now what's this last thing? Using Gary's age, come up with an expression that represents your age in terms of G.
That was kind of hard.
It is?
Yeah.
What? So how old is Gary?
11.
So how old are you?
I'm 19. I had to do like 3 G, something like that.
Well, yeah, if you want to do more than one operation, you could do that. You could just put that. I mean, but yeah. So all right, you could say 3G. That's 33 minus 15, I think.
Yeah, just something like that. Yeah.
You know, so I mean, just there's a million things you could make up using 11 to get to your age, right? So just think of something. But this is a good exercise because this is kind of where we're heading with these word problems. You remember how I graded stuff?
Boys gonna see that.
Oh.
I can't be with the school teams.
Basically, as a check. You check close, so check them.
Oh, shit.
If they do
Okay.
most of it, and they got a couple wrong.
I don't need school for that.
If they do most of it, and they got all right, you check close. If they got a lot right, and a lot wrong, check
Yeah, I don't know where it goes, but I don't see it. Some shit.
Let's say if they get
Okay,
more than
so-
a couple wrong, and then if they get a ton wrong, check minus minus. Okay? Or if somebody hands in one where they only did like 2 problems out of the whole page, put a check minus minus, like, oh, they did one. That's all.
You had this one where it's like, it was a
I
class
didn't
where
see
one person did
how
it.
will be
She was the only person in the class.
bad.
And she still got all the answers wrong.
That's possible. It's possible.
That's-
All right, so we good with this? So let's move on to today's stuffs, which is
So, I don't care,
page who's committed suicide. All right. Let me actually bring this up on the screen just to make it easier. In our books, we're going to write like sort of the important steps to solving a word problem. I'm going to use this as my basis, but I'm going to actually make it a little bit shorter. If I can find my marker.
Is that what they're saying? Put that one.
Huh.
I put 5x plus x equals 17. It is
For this one, I want to do this first before we get there, okay? Here's the steps to solve word problems. The first thing you're going to do is find your X or your N or whatever letter you want to use, right? And then we're going to work backwards from there. We go backwards to create expressions. And then we're going to link the expressions together. Link them together with like plus, minus, times, division, parentheses, to build our equation, okay? With these ones, this isn't that important, but there's one step. As these get more complicated, we're going to have to add a step here. And that's define your variables. In the first few problems, though, they're just going to say, like, some number or a number. So if you want, you could actually put, okay, x equals a number. But if it's that simple, it's sometimes not even necessary. But when we start working with more complicated word problems, you're going to say, like, okay, let P equal the number of pumpkins or something like that, right? You want to actually set it up so it makes sense. Like use a letter that sort of makes sense for the problem. Especially when we start going to things with two variables, that gets really important. Because otherwise you get confused about which is which. Like if there's some problem where they're talking about markers and pencils, you want to use M for the markers and P for the pencils. Because otherwise, if you use like X and Y, it's easy to get confused about which was which, okay? If you use letters that mean something, it's harder to get confused. So sometimes when we get to more complicated stuff, before you do this, you just want to have set like do things that are called let statements, which we'll get into. Yeah, give me 1 second. Yes. That would be 3 over 2. Which I put it in backwards. Yeah, no. It's
Mr. King,
yes.
Wait,
how is this possible?
this is Stevie.
I just always wondered.
Yo,
It's just an optical
Why
illusion.
doesn't it just
are
stay
you fucking mentally
Ali,
retarded?
come on, yeah.
They would take that shit home, like, look what my teacher said.
All right. The last thing here. Once you have your equation, you solve your equation.
Mr. King, I heard you say you was hot.
Now,
You heard this, right?
solve equation, and then the last thing you do is check your answer. Are you guys writing this stuff down?
Yeah, King.
Yeah. I made it a lot shorter than writing all of this. I mean, if you want, you could just write this down. But that's a lot shorter, sort of more to the point. Oh, today's Wednesday already, huh?
Yeah.
Unbelievable. Unbelievable. I'm just going to scroll down a little bit.
I don't be staying. I be staying in the house.
Oh, so you're putting it on the top? Oh, you're doing it now? Okay. So basically, the check plus is 4 points, and check is 3 points, check minus is 2 points, check minus is 1 point.
Oh, yeah, I would do now.
Okay.
I'm not gonna be as lenient as you are, because I don't have any relationship with the team. But don't piss off the team. I feel like they could do better. They should let me teach them better.
Mr. Moore, are you writing this down? And if not, why not? Ali, did you write it down?
Yeah.
Oh,
See no effort here.
I didn't give this back to you when I went over that?
I just read that.
Oh,
What if they do like absolutely nothing? I pick 3 minuses. All of those.
well, I'll give her one. Yeah, she won't be surprised.
She won't be surprised.
She should.
You just said good job, bro. It's sugar. This is like candy. I ain't even feel it.
Hey.
Oh, my language. Yes. Hey, I ain't gonna lie. I'm still living crazy, bro. In the hospital, bro. Shit, cold. So you remember when I saw you swollen in my eye, huh? I remember when I saw you in the school, bro. Like, right at me, bro. Look at your eye, bro. Like, right after this, bro, that shit, you had a thing, people go straight red. I know my whole.
Why'd you stop? Let's go. Right.
I like how it looks.
And then we're gonna do this thing based on.
I like how it looks.
That's a solid word, what?
Swelling went down.
Solve equation. And then the last thing is check your answer. What are you looking at? Oh, steps to solve word problem. Sorry. Yeah. There is, you see the difference, right?
It was just the way you felt. Like, I got hit when I watched it. Oh, yeah. The game was
I let you $30.
drug slap.
All right, guys. If you want to continue writing that, I'm going to go over this first problem, okay? So, it says the sum of a number and 5 more than the number is 17. What's the number? How many numbers do we have here?
2.
And we're adding them, right? So, when you add these two numbers, somehow you get 17. We're going to just try a couple of guesses. Tell me what you think the number might be. Somebody just give me a number. 12? So it's the sum of a number and 5 more than a number. What's 5 more than 12? So this would actually be what, 29? So our guess was too high, right? So we're just doing a sort of like guess and check for a second. All right, so it has to be smaller than 12, obviously, right? Anybody want to try another one?
-5.
-5? We'll try it. What's,
Oh, wait, will that work? No, right?
Probably not. 5 more than that number would be 0. -5 plus 0 is -5.
No,
So,
that's not what I meant. That's not what I meant. I
Oh.
meant 12 plus -5.
you can't do that because the two numbers have to
I
be
know,
5
that's why.
apart. Okay?
That's why I was like,
All right, well, look, that's okay. So we had a guess that was way too high. Now we have a guess that's way too low. So we know the number is going to be between -5 and 12. So somebody give me a number in there. 8? So 8 plus, what's 5 more than 8? 13? And what's 8 plus 13? 21. We need it to be 17. Well, we're a lot closer now. We have to go down some now. What do you want to try? 5?
5 more. Oh,
5 more than 5 is 10, right?
that's close.
All right, that's close. So now we're too low. We're low by 2.
Yo, 6, not trying to
6?
Alright,
What's 5 more than 6?
yeah.
So 6 plus 11?
Let's get it.
That's it, right? Now, let's say instead of 17, I said the numbers equal, 1,160.
like that?
No. we're not going to do this. I'm just showing you why we want to do it the way where we actually write the equation and solve it. This is just to show you like how much work you'd have to do without doing it the real way. And like, you know, it only took us like 4 guesses, but like if this, instead of 17, if this had been like, you know, 958, it would have taken us probably more guesses, no? So now we're going to just solve it. Instead of just doing this guess and check, we're going to solve it. So let me erase this, all right? If you want, you can leave this for the first part. We're going to solve it down here. I have to get rid of everything.
So do I have to write that or no?
You don't have to. I mean, do we agree that doing it this way is too much work? Okay, that's the main thing. So now let's carefully set up let statements and an equation. So the sum of a number and 5 more than the number. Are these different numbers?
Same numbers.
The same numbers. How many variables do we need? 1.
Oh, 1.
Right? So let's say let n equals the number. I chose n, and you could use x. It doesn't really matter. Okay. Now we're going to see if we can come up with an equation. The sum of a number. Sum is which operation? So it's going to be n plus something, right?
Oh.
The sum of a number and 5 more than the number.
The second box?
How do we write 5 more than that number? Huh? Something plus 5.
5
Huh? N plus 5. Good. So it's, and 5 more than the same number is 17. How do we write is in math? Equals. Good.
See what I did was 5x plus x equals 17.
I
Same
think
thing.
that one variable.
There is one. It just appears
Oh, the
twice.
same.
Right?
The same thing?
I mean, it could appear, these are the same number, yeah.
I wasn't gonna
I put
say it.
5
X
x plus x.
Oh, no.
equals 17.
Yeah, no, that won't work because there's nothing about multiplying. 5 more than is you're adding 5 to it, okay?
Yeah.
So does this look good?
Yeah.
How do we simplify this?
Combine like that.
To what?
2n
2n plus 5
equals 17.
equals 17.
Subtract the
Now we're just going to solve for n, right?
There you go.
Take away 5 on both sides.
12.
12.
We got 2n equals 12.
As is from there equals 6.
Divide both sides by 2. Yeah, n is going to equal 6. Right? A lot simpler. And again, with 17, it only took us 4 guesses, but if that was a bigger number, it would take too long. This is a much easier way to do this now. So the first thing, you always get in the habit of writing a let statement, even if it's a simple problem like this. Okay? Just say let n equal the number. Because the key to these problems is going to be organizing things. And like the problem that we did with the different ages and stuff, if you have like separate let statements, it's going to make it easier. Marcus, you want to wait? You have to sit up. Ali, you got to sit up. No, I said sit up.
Wait, so what do we write in for part A?
That was the thing I did with the guesses. Here they would just say like try some guesses to get to the number.
They mean
So, you know, you could have wrote that stuff. You don't have to. It doesn't matter.
what they mean by let statements.
That's this. That's where you say,
Oh,
okay,
that-
let me name my variable. In this case, it was just let n equal the number we're looking for. But get in the habit of using them, because when the problems get more complicated, you might have more than one let statement. And, you know, if you already are doing it, it's going to make more sense, okay? We want to keep things organized. You see, that as the problems get more complicated, the more organized you keep things, the easier it's going to be for you. Okay? So we good with this? Let's go down to the next one. See if I can actually do it up here. Okay. Exercise 2 says the difference between twice a number and a number that is 5 more than it is 3. So how can we write an equation based on what they're telling us here? First of all, the difference. What operation is difference? Subtraction. So we're going to be subtracting 2 things. The difference between twice a number. So a number is your n or your x, right? They're using n here. So how do you write twice n?
20.
Good. And a number that is 5 more than it. The it is your number again, right? So how do we write 5 more than n?
Yes, parentheses.
Say again?
Numbers.
Okay, but parentheses what?
Amplify.
Good. In this case, it's important you have the parentheses here. Whenever you have a minus, because if you don't have the parentheses, you're only subtracting the n from the 2n. You're not doing anything with the 5. Everything here has to be subtracted by that. Okay. You can also, if you want, you can put a parenthesis there. Because subtraction is always something minus something. But this one is the important parentheses because this tells you that both of these things are being subtracted from this. Okay. If you didn't have the parentheses, you're only subtracting the n from it. You're not subtracting the 5 from that. So that's the important part.
And it's 3.
Which one is it?
I'll question it.
Oh, wait. It equals 3. There, do that. So which one is the answer?
It's 4. And 4.
Oh,
Yeah.
Well,
Good.
yeah, you exactly wrote that same thing.
Well, I know what I'm doing sometimes. You know. For a second there, I was going to say it was number 1, but it doesn't have the parentheses, right? If this just had that parentheses, that would have been right. But since it doesn't, that one's wrong. Okay. Make sense? Now notice they're not even asking you to solve for it. They just wanted you to get practice writing the equations. Okay. Because if you can't write the equations, you're not going to be able to solve the problem. Everybody okay? Damn right you're okay. So now here's where it gets more complicated. But again, if we do this like in an organized manner, it's going to be easy. Well, it's going to be easier. Now I'm just going to read it through, and if you just like read it through without breaking it down, it sounds like it's a big mess. Evie and her father are comparing their ages. At the current time, Evie's father is 36 years older than her. 3 years from now, Evie's father will be 5 times her age at that point. How old is Evie now? A lot of stuff going on there, right? Let's actually set this up.
We did this
We did this one? When?
for the homework. The homework was it the day before yesterday? Well,
Did anybody else? Does this sound familiar?
Yeah, I did this already.
Maybe you did it the day I wasn't here?
Yeah, the day you was there.
Okay. I'm going to pick this up tomorrow, okay?
The way they told me how to do it, current and future.
Yeah.
And you do it.
All right. I think somehow you must have got it. I don't think they. We'll pick this up.
Okay. I'll see you when you get cast in her. I'll see you cast in her too. I'll be back by lunch.
Okay. No problem. So the file I gave you, that was just like one few. Hopefully you're seeing the same name.
Okay, you need the classwork too? Like I gotta give you classwork now.
Today's classwork?
No, I'm saying for like, since.
The only time you have to give me classwork is if you were absent that day and you said, let me make it up.
Okay.
If you're here, I give you the credit for it. Right? Like, all they have to do is remember the people who don't do it, which isn't many. All right.
All right, so I only have this one.
Keegan, shut it off.
Well,
You alright?
huh? Oh, yeah, thank you.
See, I gotta remember you.
I'm telling you.
I'm telling you, like.
Well, yesterday I remembered it, though.
Yeah, but now I gotta get paid for it today.
Thank you.
Anything
That
else?
helps.
I wanted to write comments.
Yeah, well, you have to stifle that.
Because they are right there, and then they just don't finish it. Like, you're right there. And Brittany, she's really smart, I see. And she applies.
Well, also, she has cast in first grade, I think. So cast
Oh,
and helps
yeah,
her with some of her
cast.
stuff.
But some of them
But no, she's not.
I
See,
see,
I
I
thought she was
different.
really smart too, but I gave her a quiz last week and she didn't do it. So like it might have been her head was in the wrong
No,
place.
but that's the thing though. That's what I wasn't understanding. Like some papers should do everyone right, and some people should do everyone wrong. I'm like, now that you said you got casting too, And it's like, you know, Cassie sits there and you go through it, and two, she basically gives you the answer, but make you get it real.
Well, you know what I think the problem is, I've been letting Brittany go ahead, because of what she do this stuff. I think I'm gonna have her stay with the class, and I'll just, she'll learn it twice, and she'll know. Okay, that's good.
Yeah.
Thanks.
Oh man. So the Brandon kid that you just got?
Brandon Nixon.
No. Gonzalez, not Hernandez, a new kid last name Hernandez? You got him yesterday?
Never heard of him.
You got a new kid yesterday.
Unless there was a kid and I said, you know, what's your name, Brandon? And I assumed it was Brandon Nixon because there was Brandon Nixon on my list. And he hasn't been here, and so I was like, oh, I assumed that was him.
There's another kid that you should have gotten yesterday. 7th or 3rd?
Oh. Well, this guy I think was first period.
Brandon?
Brandon Nixon.
Maybe first period.
I mean, unless I'm
Not
just
Brandon Nixon.
imagining.
Brandon Nixon's like 20.
Do you know who Brandon Nixon is?
Yeah.
Is he like light skinned guy?
Yeah.
Oh, okay. That's what I guess it was. Oh, maybe it was 7th period. I don't even remember. Oh, he's 2nd and 6th, Brandon.
Right, not him.
Okay. So I don't remember another student. I got a new student today. In the second period.
Oh, was it
A
the
girl.
girl though? No, this is
Brianna
a boy.
Bell.
Brianna
I
Bell.
don't, yeah. No. That's what she told me.
No, that's her name. She's not new.
She's not?
I had her last semester.
Oh.
She showed up twice.
Oh. Okay.
She did one of them kids. She's really, I can't even, she's a sweet girl.
Mhm.
I don't even know her.
Okay.
There's a,
So I don't know. I didn't get anybody else new unless somebody was
Unless
here
there's
and I didn't even
another-
notice them.
possible.
Hmm.
Possible.
Hmm.
Okay.
Especially, but I give out the calculators, so if there was somebody new, I would think I would have noticed. You know? You sure they were in yesterday? Maybe they didn't know they were supposed to come to me?
Today.
Maybe they didn't know they were supposed to come to me?
No, because I thought that it was, Dakota that said something.
Unless I thought it was Brandon Nixon and he was Brandon somebody else.
Oh,
You know, because I don't even know who Brandon Nixon is.
he's,
And
Right.
yesterday was the first day he was here.
yeah, that's cousin.
So maybe it's a different.
Brandon Nixon, he's old, he's about 20, he never showed up for the integrated. He's not a dumb kid, but he has no clue about how to work.
Was it possible that this new Brandon, I thought he was
It is
Nixon? Okay.
Because the new Brandon, remember Almo?
Yeah.
That's his brother,
Oh, okay. So maybe that's him.
possible.
Because he didn't show up, and I just assumed it was Brandon Nixon. He said his name was Brandon. I assumed it was
Yeah,
that
it's probably not.
Okay.
All right, so just get his, I think it's
Okay.
Hernandez, Brandon Hernandez.
guy. Okay.
He's probably not in your Jupiter yet, so.
Okay. All right, that solves one mystery.
Yeah.
What happened to Brandon Nixon then?
Who?
Brandon Nixon. I guess he hasn't shown up then.
I saw him yesterday because it's funny. I did see
Oh.
him yesterday.
All right, I don't know. We're gonna have to
Hold
figure
on,
this out.
yeah, don't do anything yet.
It's like Nancy Drew mystery.